Hello students, we are going to discuss about rate of drying for continuous direct heat dryer. Direct heat dryer fall under two categories, namely whether the high temperature or low temperature prevail in the dryer. Material balance general expression for dryer, solid is entering in one direction, gas is entering in opposite direction. The flow is a counter flow fashion. Are you clear on? Okay. So generally Gs into dy is equal to Ls into dx. This is fourth expression. Substituting for dx in equation 3 from equation 4. So what is the dx from equation 4? Dx is equal to Gs by Ls into dy. Are you clear on? Okay. Substitute this dx value in equation 3. What is the equation 3? To refer the yellow color box or refer the previous slide. T2 is equal to Ls by A integration of x3 to x1 dx by ky into ys minus y. Are you clear on? Okay, this is the third expression. So the substitute dx value in this expression. Finally we get T2 is equal to Ls by A. What is the dx here? Gs by Ls into dy. Gs by Ls is a constant, take outside. Integration part, x3 to x1 means in y part the change the integration limit, x goes to yc, x1 goes to y1. So here dy divided by ky into ys minus y. This is equation number 5. So for this case ys, that is saturation humidity, to be constant. So the corresponding to saturation humidity at the Weber temperature of incoming air, there is no heat loss under adiabatic operation. So here the integrate with respect to y. So substitute the limit yc to y1. So this result T2 is equal to Ls by A, Gs by Ls. 1 by ky is a constant. You take outside all the constant. The integration part, integration of yc to y1 dy by ys minus y. So the what is this result? So the integrate with respect to y. Finally we get minus ln of ys minus y. So I'll substitute the limit yc to y1 minus ln of ys minus y1 plus ln of ys minus yc. Upper limit minus lower limit. So after applying the formula ln A minus ln B, finally we get ln of ys minus yc by ys minus y1. So the final expression T2 is equal to Ls by A into Gs by Ls into 1 by ky ln of ys minus yc by ys minus y1. This is equation number 6. Next one, zone 3. In this zone, bound moistures are removed. So the x is less than xc. We have capital N is equal to Nc into x minus x star divided by xc minus x star. This is equation number 7. So this equation taken from time of drying falling grade period. These videos are available in Moodle. You refer the video. This equation taken from that part. Are you clear? Okay. So this is falling grade period. So whereas constant grade period, general expression, you refer the yellow color box. N is directly proportional to change in humidity. Remove the directly proportional. We are adding the constant mass transfer coefficient. N is equal to ky into delta y. So the delta y for this case, that is ys minus y. Finally we have N is equal to ky into ys minus y. At the constant rate period, N is equal to Nc. This is a final expression. Nc is equal to ky into ys minus y. This is equation number 8. So this equation also available in that part time of drying. You refer that video. These two equations, because 7 and 8 expression taken from time of drying, falling rate period and constant rate period part, refer that video. Substitute equation 8 in equation 7. Capital N is equal to ky into ys minus y. So the replace the Nc value into x minus x star divided by xc minus x star. So this is equation number 9. Are you clear or not? Okay. Substitute in equation 2 from equation 9 we get What is the equation number 2? Refer the yellow color box. T is equal to T2 plus T3 Ls by A integration of x3 to x1 dx by n. This is the second part. Third part plus integration of x2 to xc dx by n. Are you clear or not? Okay. Well, now we want T3 value, that is zone 3. Time retention term T3 is equal to Ls by A. Here that is integration of x2 to xc dx divided by, what is the capital N? Capital N taken from equation 9, ky into ys minus y into x minus x star divided by x minus x star. So here x minus x star goes to numerator. Finally we have T3, that is zone 3 retention term, is equal to Ls into x minus x star by A into ky integration of x2 to xc dx divided by ys minus y into x minus x star. This is equation number 10. This cannot be integrated directly as y, also varies with the x. The simple material balance gs into dy is equal to Lx into dx. dy is the y minus y2, dx is the x minus x2. So the simple material balance is gs into y minus y2 is equal to Ls into x minus x2. From that, capital Y is equal to y2 plus x minus x2 into Ls by gs. This is equation number 11. Cumulative Ys, that is saturation cumulative, can be determined from the cumulative of capital Y1 of inlet gas. X star can be determined experimentally for the given cumulative capital Y2. X star is the equilibrium moisture content. By substituting for capital Y in equation 10 from equation 11, we can estimate T3 value. For this case, x star equal to 0. We shall analyze the equation number 10. By differentiating equation 11, we get gs into dy is equal to Ls into dx. Are you clear? Okay, this is general expression. Differentiate with respect to y. gs into dy is equal to Ls into dx. This is equation number 12. From equation 12, dx is equal to gs by Ls into dy. This is equation number 13. Substitute equation 13 in equation 10. What is this equation 10? You refer the yellow colored box. This is the equation 10. T3 is equal to Ls into xc minus x star divided by A into ky. Integration of x2 to xc dx divided by ys minus y into x minus x star. So this expression, substitute dx value, d instead of the dx, gs by Ls into dy. So change the integration limit, x2 is equal to y2, x is equal to yc. So after substituting this value, finally we get T3 is equal to Ls into xc minus x star divided by A into ky integration of y2 to yc gs divided by Ls into dy divided by ys minus y into x minus x star. Are you clear or not? Okay. So here x star is equal to 0. That is equilibrium moisture content. After substituting this value, finally we get T3 is equal to Ls into xc by A into ky gs by Ls. Take outside 1 by x integration of y2 to yc dy divided by ys minus y. So Ls into xc by A into ky gs by Ls into 1 by x. This integration with respect to y, substitute the limit y2 to yc. The integration value minus ln of ys minus y. The limits are y2 to yc. Substitute the limit, upper limit minus lower limit. Finally we get Ls into xc by A into ky gs by Ls into 1 by x. Ln A minus ln B ln A by B ln of ys minus y2 by ys minus yc. Are you clear on that? Okay. So here capital X. So how will you calculate the capital X? From equation 11, refer the previous slide. In yellow color box, capital Y is equal to y2 plus x minus x2 into Ls by gs. So from that capital X value, y minus y2 into gs by ls plus x2. So for this case, equilibrium constant or moisture content equal to 0. So in this case, the humidity are saturation humidity. So that's why, so capital Y is equal to Ys, substitute here, capital X is equal to Ys minus Y2 into gs by ls plus x2. After substituting this value, finally we get T3 is equal to ls into xc by a into ky, gs by ls into 1 by ys minus y2 gs by ls plus x2. Substitute the x value here, ln of ys minus y2 by ys minus yc. This is equation number 14. From equation 10, T3 is equal to ls into xc minus x star by a into ky, integration of x2 to xc dx by ys minus y into x minus x star. So for this case, equilibrium constant is equal to 0. The humidity values are outlet humidity, that is y2. So here ls into xc by a into ky, ys minus y2 take outside, integration part x2 to xc dx by x. Dx by x integration ln x. After substituting the limit, finally we get T3 is equal to ls into xc by a into ky, ys minus y2 into ln of xc by x2. This is equation number 15. Combine equation 14 and 15. Finally we get T3 is equal to ls by a into xc by ky, gs by ls into 1 by ys minus y2 into gs by ls plus x2 ln of xc into ys minus y2 divided by x2 into ys minus yc. So why? Because after combining these expression 14 and 15, ln of a into ln of b, so that is the ln ab. Are you clear or not? Okay. So the above equation cannot be applied when the internal diffusion control the drying process. So we have assumed that in the falling rate period, drying rate varies linearly with free moisture content. Whenever the drying is controlled by internal diffusion, T3 can be determined experimentally. Thank you for your attention.